Okay, let's try this again. I'm back. I messed it up the last time I tried it. I'm going to take this and I'm going to modify for the second problem where we have y prime plus y equals f of t, and y of 0 is 1 and f of t is 1 as well. The problem that we were doing before. So I'm going to just go ahead and modify the Simulink model that we already have. Okay, and I need those library terms so I can bring those in. Okay, and I'm just going to go to the commonly used blocks. I'm going to do this modification. I am going to need a summing block. Okay, and even though our gain is 1, okay, let's do this. I am going to use a gain here. Okay, so let's see. I think the gains are in here somewhere. There it is. And I like to flip this around just so that it's nice and neat. So we'll flip the block so it's facing the right way. Okay, and let me just say, oops. There we go. Okay, so if we look at this, we have, y prime plus y. Now our input is the f of t. Okay, and so into this integrator that we have here, we got to bring a feedback from our y term. Okay, and that's what we're kind of doing here. We're bringing that feedback. That's this one term. If it was 5y, this would be a 5. Okay, and so on. Now, in our case, the initial condition is 1. That hasn't changed. Our gain is 1. This has to come back as a minus. Okay. And our constant now is 1. So let's go ahead and we have all that together. We'll turn on our scope and bring that over here so we can see it. And when we run it, we had better get 1, and we did. Okay, so let's modify this a little bit, okay, to make it more interesting. This is a very boring problem. Let's come back here. Okay, so I'm going to write this in here. Okay, we'll do a thought bubble here, and right here. Let's see if I can move this over here. Thought bubble. We're going to make y prime plus 4y equals f of t. Same values for f of t and for the initial condition. Okay, so that's what we're going to change our equation to. So let's see how we'll do that. First off, our gain is now going to be 4. Okay, and I left this the same. Okay, and yeah, I think that's the only change that I had to make. Okay, and we see immediately, even though we're putting in 1, our system is actually going to 1/4. You can see that. Okay, so, and that's really not what we want. Okay, so if you think about this right here, that's our system, and that's not going to change. Okay, it is what it is. It's whatever your differential equation is. And our constant, what we're trying to get to, 1 isn't going to change. So what we need is some kind of controller that's going to help us maintain that 1, okay, with a feedback loop. So that's what I'm going to do. I'm going to go to continuous. I'm going to grab a PID controller. I'm going to get rid of this. Okay, put my little PID controller in here. I'm going to need a feedback. So I'm going to need another one of these blocks. So grab another one of those. Okay. Let's just connect everything up. Okay. And I'm going to do this as I showed it in class outside of that. Okay. So now I've got my feedback loop for my PID controller. And if I run this, you'll see it's trying to get to 1 now. But it's not doing a great job. But the PID values were just proportional was 1, integral was 1, derivative was 0. So it was just a wild guess. Okay, so let's go ahead and let MATLAB tune this, which is kind of neat. Okay, it's tuning. Okay, and the tuner comes back, and here we have it. Oops. Okay, and that looks pretty good. It goes to 1 pretty quickly. I'm going to apply it. I'm going to save it. Okay, so here's my new values. My proportional is 5.27, my integral is 35.7, and my derivative term is 0.274. Okay, And let's see what it does now. Ooh, that's pretty good. It goes to 1 pretty quickly, and it stays there. So not too bad, okay? So I will have a homework problem based on this.